Alright, ladies and gentlemen, here we go. We're going to be taking a look at our Chapter 8 review, okay, which is on logarithm, exponential growth, decay, so on and so forth. Let's get cracking. Graph the following functions using the y-intercept and the asymptote. Complete the blanks below. Okay, the first thing you guys can do is check out your asymptote. You'll notice I have nothing tacked on here, okay? So my horizontal asymptote is just y equals 0. My domain will always be negative infinity to positive infinity. I know that because every exponential growth or decay model that we have, which will be growth, is due to that fact. My y-intercept is when I plug 0 in. So if I plug 0 in up top here, 3 to the 0 power is 1. There's my point. And let's take a look. Okay. So 0, 1 is right here. Okay. It's a growth, so it's going to be shooting up this way. So it's looking like here's my asymptote going across. You can gladly use the graphing calculator for this. Done. Alright, and to get another point too, I could plug a 1 in and that would give me 1, 3. If I plugged a 1 up here, another point on this would be 1, 3. There you go. Now, this, I'm pleased to see you guys doing a nice job with this. As x goes negative infinity, as I go this way, where is your graph going towards? It's going towards the asymptote, which is 0. As I go to positive infinity this way, which way is it going? Positive infinity. Okay? And you're all set. For number 2, let me show you guys how to do this one in the graphing calculator, give you a little heads up. Okay. So we are looking at parentheses 1/4 raised to the x minus 1 plus 5. Okay, and I can graph this. Never guess what my domain is. Okay, my domain is negative infinity to positive infinity. My horizontal asymptote is the thing tacked on the end, 5. I mean, just by looking at my graph here, as I go to the left, it's going to positive infinity. As I go to the right, it's going towards my asymptote, which is 5. And as far as my y-intercept goes, I can go ahead and pull this up. 0, 9, so 1, 2, 3, 4, 5. This is my asymptote. 6, 7, 8, 9. And a second point would be 1, 6. There we go. Okay, so your y-intercept is 0, 9. You're all set. So all of this can be done via graphing calculator. Please feel free to do so. Number 2, rewrite the following logarithmic equation in exponential form. You take the base of your log, you raise it to this power, and you set it equal to what's over here. So 3 to the 4th equals 81. And you are set. That's it. This is exponential form, this is logarithmic form. They are equal to one another. Okay? Part 3. Simplify the following expressions, leave your answers in terms of e, which means don't put it all in the calculator. This 3 can go to both terms. 2 to the 3rd, e to the, I can multiply these, negative 15. 2 to the 3rd is 8, negative exponent, I flip it. Done. Okay. On the right, I'm combining like terms, so I'm doing 3 times 4 times 5, which gets me 60. These are all base e, so I add my exponents. I'm looking at x minus 1 plus negative 3x plus 6 plus x. All I'm doing is combining like terms at this point. 60e x minus 3x is negative 2x plus x is negative x. Negative 1 plus 6 is 5. And we're good. Looking solid. Okay? Good so far. On the back. Perform the indicated operation on each logarithmic expression. We are expanding it. So log base 3, 9x to the 3rd power, y squared z divided by w. Every term's got to get a log. So let's do this in 2 steps, okay? I got log base 3 of 9. We split up multiplication with a plus sign. Log base 3 x to the 3rd plus log base 3 y squared plus log base 3 z, and then because I'm dividing by w, I do a minus log base 3 w. We're so very close to being done. The last thing you have to do is take your exponents, and pop them out front. So it looks log base 3, 9 plus 3 log base 3x plus 2 log base 3y plus log base 3z minus log base 3w. Every single term has its own logarithm, base 3, and you're set. Number 2, we're condensing, doing the reverse. So the thing out here is your exponent. So when I rewrite this, I have log 81 raised to the 1/4 power. Minus means divide. You see how I have parentheses around this entire thing? Let's throw parentheses around this entire thing. 6 to the 2nd power divided by 4 raised to the 1/2 power. Now this might be really freaking you out right now, but take your time and just go stick with what you know. 81 raised to the 1/4 power, which you may use a calculator for, but you guys should know that's the 4th root. The 4th root of 81 means 3. Down low. 6 squared is 36. 4 raised to the 1/2 power means square root, which is 2. Just clean this up down here. Log 3 divided by 36 divided by 2 is 18. Okay? And then 3 over 18 can be reduced down to 1/6. And you're all set. Okay? Awesome. Solve each equation, round each answer to the nearest thousandth. 8 raised to this power, 2x plus 1 equals 4 raised to 4x minus 2. These both can be reduced down to a number raised to a power to get each of them, the same number. So in this case, 8 I can rewrite as 2 to the 3rd power, which is 2x plus, or times the quantity 2x plus 1. On the right, I can rewrite 4 as 2 squared, 4x minus 2. Okay? And then, same base, all I need is to have my exponents be equal. So I can say 3 times the quantity 2x plus 1 equals 2 times the quantity 4x minus 2. Distribute the 3 in. Distribute the 2 in. Let's solve. 7 equals 2x. Divide, x equals 7/2. Or you could put down 3.5. I prefer improper fractions, but either one will be correct. Okay? Actually, it says round nearest thousand. Sorry, read directions. So 3.5 would be your answer. Okay? Cool. Now, natural log of the quantity 5x minus 7 minus natural log of 2x plus 1 equals 0. Let's get this moved over. Natural log of 5x minus 7 equals natural log of 2x plus 1. I have a natural log equaling natural log. I know that what's in the quantity here has to be congruent, or equal rather. Solve. Add 7, add 7. So x equals 8/3, or 2.66. There you go. Our nearest thousandth, this should be rounded to nearest 6.2. Sorry, 2.67. Blah. There we go. Okay? Awesome. Number 3. Now, don't get trigger happy with this. Doing 5 raised to this power equals this. Before I do that, I gotta get rid of the 7 out front. So I have to divide both sides by 7. Log base 5 of 2x plus 1 equals 3. Now I can do 5 raised to the 3rd power equals 2x plus 1. 5 to the 3rd power is 125. You use your calculator for that if you need to. (124) equals 2x. X equals 62. Okay? Cool. Alright, last one on this page then. What we're taking a look at is we can say log base 6 3x plus log base 6 x minus 1 equals 2. When you're condensing logs, see how up here, I was expanding and condensing? Plus sign means multiplication. So I want to condense these down to one log. So it goes log base 6 3x times x minus 1 equals 2. Okay? Log base 6, I can multiply the 3x into both of these. I get 3x squared minus 3x equals 2. And you just rewrite it now. So I can do 6 raised to the second power equals this whole quantity right here. So 6 squared equals 3x squared minus 3x. 6 squared gives me 36. So 0 equals 3x squared minus 3x minus 36. I can divide everything by 3. Oops. Okay. That's an x squared. My apologies. Factor. I mean, we've learned this since the beginning of the year. Negative 12 goes on top. Negative 1 goes down low. Can you think of two numbers that multiply to give you negative 12 after negative 1? Negative 4 and positive 3. So I'm doing x minus 4, x plus 3. Set them both equal to 0. X equals 4. And x equals negative 3. Now here's where I was saying to you guys, you got to be careful. Okay. These both, alright, if I plug them back in, you have to check to see that everything inside the parentheses up here is positive. So for the first one, 4 times 3 is 12. Okay, 4 minus 1 is 3. That's fine. Alright, I mean, the rest of it will work out. You can go out and use your calculator. If you add those two together, they'll equal 2. But if I plug a negative 3 in here, 3 times negative 3 gives me negative 9. Log base 6, negative 9 does not work, does not exist. This is called extraneous. So long story short, once you get your two answers here, you're plugging them back in, okay, and you're just making sure that you never have a log with a positive or with a negative number in here. If you look back at all my previous answers, okay, number 3, if I plug 62 up here, 124 plus 1 is 125, I was fine there. 2.67, if I plug it in here, they're both positive, we're okay. And then over here, we're okay because we weren't even dealing with logarithms. So that's what we're looking at. Therefore, down here, the only answer that works is x equals 4. So there's your first page. I'm going to work on getting you guys the word problems done next. Okay. So as always, keep up the good work and good luck. We're all counting on you.